Hello everyone, welcome to the first tutorial session for the natural language processing course. So, in this tutorial session, we will be seeing how to set up the programming environment for the course and how to use it to solve your assignment problems. So, we will be using Python as our default programming language and we will be using Jupyter as our default programming environment. So, if you are already comfortable with a particular programming language or an environment, it is perfectly fine that you use one of those. But if you feel that you will be requiring our assistance, it is recommended that you use Python and Jupyter. So, let us see how to install a programming environment. So, what I will suggest is that you can go to Google and type Anaconda Python. So, Anaconda is a package that gives you the programming language, programming environment and all other necessary packages required to run your codes. So, you can see that the first link here, which is the Anaconda package, leads you to the download page. So, if you do not get here, you can go to the menu and see the download link is up here. For installation, you can look into the packages here. As we can see, the package is available for different operating systems and we recommend that you go with the Python 2.7 version. So, depending on your OS, you can install the 64-bit installer or the 32-bit installer. So, if you are working on OS X or Linux, your installers are available here. We recommend that you install the command line version and go to the particular directory where the package is downloaded and run your bash command to execute this particular package. The command line installer will take you through and it will show you how to install the package. For the Windows, the graphical installer is available and you can download it by clicking on this particular link. As I have already have the installed version available with me, I will be showing you a step-by-step process of how to install this setup. So, if you have space constraints, you can try the minimal package called as Anaconda. Otherwise, it is advisable that you go with the current installation, which is Anaconda. So, here is the installation package and you can go to a step-by-step process and yes, it asks for two separate ways of installation. If you do not have admin privileges in the particular system you are installing, you should be selecting this one just for your particular user and you can define where your package should be installed and make sure you have at least 2 GB of free space available in your system. It is just that I have already a package installed. So, I will be just showing you how to install it on a separate folder and you have to just make sure these are ticked and click on the install button. So, the install will take somewhere around 15 to 20 minutes to complete and once it is completed, you will be able to see the Anaconda package in your programs and once you click here, you can see different packages installed where you should be selecting Jupyter Notebook. So, Jupyter Notebook is a programming environment that runs from your browser. So, it has a server running at the back and I have an instance of Jupyter already running in my browser. So, it by default goes to your document folder, and within the document folder it will show you where exactly your files are residing. So, as part of the assignment we will be providing you some helper files, of which this is the particular programming file that you should be looking for. So, this is your programming environment. So, notebook is not just a programming environment, it helps you keep note of things that you learn, it helps you document the stuff that you basically go through, so that you can refer it back. So, I will be using Python as my language inside Jupyter, and Python also tends to be my favorite calculator. For example, if you want to calculate just some values, I can just see how multiplication of two values gives me an answer. So, 987 into 543 will give me this particular answer. Now, if I want to store using my variables, I can give the values to the variables. There is no type declaration as required. You can just give a variable name, say maybe I can give variable 1 and this will be variable 2 and C equal to variable 1 plus variable 2, and then I print the value for C. Now, assuming since we are studying about natural language processing, we will be taking a lot of strings and a lot of textual data to handle. We will how to store text strings. So, if you have a variable, you can just assign text strings enclosed within quotes. So, here I have typed hello and world, and I do the plus operation to both the variables. Let us see what happens. So, the particular variable prints hello world together, which means it concatenates both the variable. So, this automatic identification of whether the sum needs to be done or concatenation needs to be done is handled by the Python interpreter. Suppose if I change and I say hello MOOC, let us see how it differs. Yes. So, the output given here basically shows hello MOOC. Similarly, a variable initialized at a particular cell can be reused at another cell as it resides in your memory. For example, I reuse the hello which is already there in which was already defined in the particular cell here, and I use hello NPTEL. Let us see how it comes, it works. An important thing that you have to take care is indentation. So, when using conditional statements like the if or the loops like the for loop, you have to make sure that the block indentation is maintained. So, what I want to check is that if a is equal to hello, so I check for whether the variable a contains the variable hello, then the variables are given the values 1 and 2, otherwise the variables b and c are given the values 10 and 11. Let us see which value gets printed. Since the variable a has the value hello, it prints 1 and 2. Suppose I change it to NPTEL and execute it, and now I run here. So, here I get the values 10 and 11. So, if you are still confused how to run the code after typing the code in the particular cell, you can either use the shortcut control and enter, or you may go to this button and this will execute the code. So, let us change the variable values here and see if what happens if we run the code. Now, b gets the value 60 and that gets printed here. Now, suppose I am using a loop to print all the values between 1 and 5, that is 1 to 4, how do I do? So, I define the keyword 4, I define a variable and I define that the variable will be within a range from 1 to 5. If we can make it 7 or any value of your choice, and let us see. So, it prints all the values from 1 to 6. If I do not want to print it line by line, I can just use a comma here and it gives me the values written in the same line. So, this is some basic syntax that will let you code in Python, and we recommend that you go through some of the basic tutorials regarding Python and some of the basic data structures that Python has, so that it will help you in making your coding experience much better. So, in order to provide that, we will be providing you some links and some resources that you can go through and get freshen up with the particular code. So, as part of your assignment, you are supposed to solve questions that involve edit distance, that involves calculating the likelihood using bigrams and unigrams, and I will be showing you how to handle this. So, as from the week 2 lecture 1, you might be aware of the concept called as edit distance. So, edit distance is a particular function that helps you compare two strings and find the similarity between them. So, the edit distance gives you the minimum distance between two strings, and the minimum distance can be calculated in terms of the number of operations that require to change one string from to another, and this is defined in terms of 3 operations: insertion, deletion and substitution. So, we have provided a function called Levenstein that helps you execute or calculate the edit distance. So, this is how functions or methods are used in Python. We use the keyword def followed by the name of the function, and since I have 2 strings to compare, I give the 2 strings as my function arguments, that so that when you call the function, you have to give which are the 2 strings to be given. Now, these are the 3 operations, the insertion, deletion and substitution, that you will be using to compare both the strings. So, you need not worry about what exactly is happening inside. You can think of it as a black box and you can just execute it, but if you are curious, you can obviously work around with it, hack around with it and see how the output changes. So, assuming I already have the code set up and I already executed this particular cell, so that the function goes to gets invoked. Now, I call this function Levenstein and I give 2 strings, which is HELLP and HELLO, and I want to see what will be the difference between the strings, or what will be the edit distance. It turns out that the edit distance is 1, which is being returned by this particular variable here. Suppose I want to give yes, it also gives the same values. So, if I have a new string, the value changes. As part of your assignment, you have one question where you are supposed to solve a problem using the Jaro-Winkler distance. Jaro-Winkler distance is a variant of edit distance that is used to compare strings, and we have provided the explanation of how to calculate the Jaro-Winkler distance between 2 strings, and you can read about more in the Wikipedia link provided. But for your convenience, we have already implemented the Jaro-Winkler as a function, and we have stored it in the package edit distance. So, you can call the Jaro-Winkler function and you can again assume it to be a black box just to solve your assignment. So, in Jaro-Winkler, as you can see, the value ranges between 0 to 1, and so if 2 strings are exactly the same, they will provide you a value of 1, and if they are completely different, they will provide you a value of 0. So, if I give the same string, I get a value of 1 as my Jaro-Winkler distance. So, this is very useful when it comes to compare strings such as person names, because there are huge variations in the person's name that we use. For example, it is very common that the word Vimal might be spelled as Bimal depending on your demography. So, suppose we apply this function and let us see how the string gets the value. So, the similarity between Bimal and Vimal turns out to be 0.867. Now, let us see, given a data set or a corpus of words and you want to find the most similar words of a given string from that, how do we do that? So, you will be provided with a file called unigram.csv. You need to load that file and you have to so every line contains a single word or every unique word and the frequency with which it appears in a particular corpus. So, I read the file to the variable unigrams and unigrams will be stored as a list. This is a default data structure used in Python. You can read more about list from the Python manuals. So, for convenience you can think of it as an array where if I want to access the first element, I just give the index of the first entry which is 0 and I print that value. So, the entry gives me foul which has a frequency of 1. Suppose I want to see the first 10 entries in the file, I will use the colon followed by number 10. So, it will give me all the numbers from 0 to 9 and that gives me the first 10 entries which is foul which appears 1 time, 4 which appears 3 times and immature appears 1 times, bringing appears 1 time. Now, I will be using a different data structure called as dictionary that helps me separate the count and the word from one another. So, dictionary is, as the name suggests, we have a key where the key is your word and when I provide the key to the dictionary, it will provide me the count with which it is appearing. So, here is the function that helps me do and it stores the value inside the dictionary called as word freak. So, once I execute it, so a dictionary has two entities. One, it is called as the keys and it maintains a list of the keys. So, if you type word freak dot keys, it will provide you all the keys that it has. Now, if I want to know how many times thunder is appearing, what I would do is I would see the count of thunder by just giving the key as thunder to the variable word freak and it appears only once. Let us see how many times hanging is appearing and let us validate whether it is coming out to be correct. It is coming out to be correct as it is 4 here and we already have checked it was 4. Now, since you know how to open a file, have to store it in a dictionary and you always also know how to compare two strings, let us see whether we can find similarity, the most similar word to a given string or a given word. So, what I do is that I iterate through all the possible words in the dictionary and then I find the Levenshtein distance between the string that I want to compare, which happens to be TORD. It is a spelling mistake. So, I have to see which word can be replaced with TORD and if you see here, I take each word from the keys of the dictionary and assign it to the variable item one at a time and I compare toward with item and I am going to print all the words that has a Levenshtein distance which is less than or equal to 1. So, if you find toward, well and good, otherwise let us see what are the other words. It turns out there are 5 words which are similar to TORD, which is Lord, Tor, Ton, Told or word. Let us see all the words which have a Levenshtein distance of less than or equal to 2. And it turns out there are much more entries which have a Levenshtein distance of 2 with the words. Now, what we will be doing is that you are given with another file called the bigrams.csv, and it contains all the bigrams with the frequency with which the bigrams are appearing. So, this is very straightforward, just like what you have done previously for unigram.csv. We are going to use the same set of code. If you see here, but here I have just written it in one line. So, I have the bigrams file which I have read and I have split it into a list. Then I define the dictionary called word bigram, and I store every bigram as my key and the count as the value. So, bigrams and unigrams are stored as now two different dictionary, one is in word freak and other is in word bigram. Now, suppose I want to calculate the bigram likelihood. As we know, the formula is the count with which the bigram occurs by the count with which the first word in the bigram occurs. So, if I want to calculate the bigram likelihood of comeback, I want to know the frequency with which comeback is occurring in a particular corpus and the frequency with which come is occurring, and it turns out that the value is occurring 10 times and come is occurring 146 times. So, if I want to calculate the probability of comeback and come, I would do word bigram comeback divided by word frequency of come, which will give me 10 by 146. But it turns out that the value is coming out to be 0. So, there is certainly some problem. The problem is that since both the frequencies are integer values, the system assumes the answer also should come in an integer, but it turns out that the value is coming out to be a floating point number. So, to handle that, there are different ways of explicit typecasting. What I am doing here is just multiply the value with a 1.0, so that before the division occurs, one of the value turns out to be a float. So, after the operation is done, the value turns out to be 0.068. Now, suppose we want to calculate the likelihood of the same bigram, but using add-one smoothing. As we know, add-one smoothing basically adds a 1 to the numerator for the bigram likelihood, and it also adds to the vocabulary size or the number of unique words in a corpus. To get the number of unique words in a corpus, we can just take all the keys in the dictionary and we can find the count of that, all the number of keys. And it turns out that the function len performs the same. So, I have used the len function to find all the length of the keys, and with that I print the likelihood after add-one smoothing, and you can also see how many unique words are there in the corpus. So, this is pretty much for what you can do with your assignment 2, and there will be one question where you are supposed to modify the cost involved for the particular operation. So, in that particular question, you are supposed to change the value for substitution, as insertion and deletion involve a cost of 1, but substitution involves a cost of 2. So, in order to do that, I am going to modify the value. So, what this particular function does is that it compares whether two characters at a position are same. So, if they are not same, it returns a 1 because this is a logical operation, otherwise it returns a 0. So, previously the cost was 1, so it was left as is. Now, since the cost is 2, I am just modifying it to be 2 here, and let us see how much does it cost to have Bimal and Vimal compared with this increased operation, and it turns out that the value becomes 2. This is generally done when you want to penalize substitutions and you want to check more into the insertions and deletions operations. And for some aspects you might require some external packages to be installed, and I will be showing you how to install an external package. Suppose I know there exists a package GenSim and I assume that it is installed in the system. I will import that external package using import GenSim, but it turns out that the package is not installed. So, Anaconda comes with a default package manager which you can select using here Anaconda Navigator. So, Anaconda Navigator provides you all the different packages and it provides a repository of different packages that you can install. Alternatively, you can create a new cell and you can install a package within the notebook itself. What you have to do is that you have to mind this exclamation mark. So, you have to type pip install GenSim and this will also help you install the particular package. But if you are having trouble with that, you can by default go to the Anaconda Navigator and it will help you install the file. So, I will just show you how to install the same, and that will be the end of the tutorial session. So, here you can click on to the environments tab and you can see for all packages available in the repository of Anaconda, and you can just type GenSim and you can click here, you can select it and you can apply it to install. As I was suggesting, you may alternatively use this command to install. If you want to create a new notebook, you should click on the new and you should select one of these. So, this will give me a new notebook where you can have a fresh notebook where you can try out code by yourself. So, this is pretty much it. Thank you.